Hello everyone, welcome to another example of Cope-Eulerian Lagrangian method. In this tutorial you're going to learn how to simulate the explosion in a soil. So what we're going to have the Eulerian domain with three different sections. So the top part is going to be air, the bottom part soil, and this small middle part is going to be TNT. So this simulation is kind of like a 3D 2D model, which means that we gonna model it as a 3D, but we're gonna give a very small thickness like 0.01 to make it similar to 2D simulation. The reason that we cannot use the 2D planner is that because we have only Eulerian domain, and in Eulerian domain you should definitely model it with 3D elements, not a 2D one. So here we're going to use a slightly different method to assign material properties. If you remember in the previous tutorial, what we have done, we had a Eulerian domain, and also we had the Lagrangian part, which was air, soil, and TNT, and we were removing those parts from the Eulerian domain. But here we're going to have a one uniform Eulerian domain, and then we're going to apply the property to each individual part. Why we use the different method here is that the reason is that we don't have a Lagrangian part, which means that we are not trying to find the effect of explosion on any specific thing. For instance, in the first example, we wanted to see the effect of explosion on a concrete beam. In the second example was the effect of explosion on a pipeline. But here, it's just only Eulerian part, so we don't really have any Lagrangian part to use the previous method. So if you want to use you choose between these two methods, you need to think about if you have any Eulerian Lagrangian part, and if you have that one, the previous method is more suitable. But if you don't have it and it's just a completely Eulerian model, then you can just use this model that you're gonna learn in this tutorial. What you're gonna expect in the results section, as you can see, we have a three plot: air, soil, and TNT. When the explosion happened, as you can see, we have this mushroom shape explosion wave, and also here at the bottom of the soil we have a crater, and as you can see, this green line is the soil that is spread on the air, and also this is the plot for a TNT. So what you need for this tutorial is the equation of this equation of state. So hopefully you have watched that theory video about the equation of state in this course, and if you have already done that, and if you're ready, let's do this one in Abaqus. So now I'm going to show you how to simulate the explosion in a soil. So for this tutorial we're gonna use only Eulerian domain. If you remember, in the previous tutorial we had Eulerian and Lagrangian body. Here we're gonna only have a Eulerian part. So go to create part and type domain and select it 3D Eulerian, and for approximate size, make this one 12, which is going to be 12 meter. All the unit that we're going to use here is going to be meter. Click on continue, and then use these two construction lines, and then go to here, create constraint, and fix them in all direction. Done. And then use a rectangle by selecting 2 points, and then say from here to here should be 4, from here to here should be 8, from here to here should be 6, and from here to here should be 12. Okay, then cancel a dimension, click on done, and then for depth give a very small value, 0.01. So as you can see, the thickness is very small. So this example is going to be kind of like a 3D 2D model, because we have only Eulerian domain, and you cannot 2D planner, we cannot use a 2D planner, so we need to definitely use 3D models. So to simulate 2D examples, what we can do, we can consider a very small thickness like what we have done here. And then I'm going to create a partition now for this one. So I'm going to select this surface, click on done, and then select this line, and then draw one line from here to here, and then draw one construction line in the middle, and then go here, fix this one, and then draw a rectangle like this. And then what I'm gonna do, I'm gonna just remove this extra line here, and then what I'm gonna do, I'm gonna give a dimension to it. So from here to here should be 0.1, and from here to here should be 0.2, from here to here 0.2. And what we're gonna do, I'm gonna go here, coincidence, select this one to go here, and then cancel this one. So now we have our TNT in the middle there, then click on OK, and done. So now I have air, soil, and TNT in the middle. What I'm gonna do, I'm gonna basically transfer the partition to the whole body, because at the moment I only have a partition in the face here, but the back, if you look at it, it's just a one face. So what? How can I do that? If I go here, this one, partition, extrude, sweep edges, then I can select all the edges here by holding shift, then click on done, and then extrude along a edge direction, and then select this line, click on OK, create a partition. So as you can see, now we have the part one separately. Now click at the bottom, click on done, and then select this line, this line, this line, click on done, again extrude along the direction, and then zoom in, select this one, click on OK, create partition, and done. So now what we have 1, 2, 3 cell, and also same thing at the back as well. Now what I'm gonna do, I'm gonna create a set for this one, because they would be easier to select them in the next step. So what I'm gonna do, I'm gonna go here, remove selected, and from here I'm gonna change this one to cell, select this one, and then go to tools, set, create, type air, continue, select everything, done, and then bring everything back, then select this one, and then select this one, done, create another set, call this one soil, and select everything, done, bring everything back. Now this time remove this, tools, sets, create, and type TNT, and select this one, done, and bring everything back. So now we have 3 sets, air, TNT, and soil. In the next step, I'm going to create a material property. So let's start with the air. General density, mass is going to be 1.225, and then I'm going to use the equation of state. And then if you go to this Excel file, at the bottom here you can find the material property for air. So by giving a gas constant and ambient pressure, and then also we need a dynamic viscosity as well. It's a very small value, so I'm going to copy this one and paste it here. And then we can also give a specific heat as well, which is 718. Then I'm gonna create a material property for soil. General density 2200. We have 2 options. We can use the equation of state using this one by using this model. So I'm going to show you. So we can go to EOS and use USUP model, so by providing these 3 constants, or we can use the plasticity, Moore Coulomb plasticity, that I'm going to use for this tutorial. So this one 24, this one very small value 0.12, cohesion yield stress 100 E3, and this one 0. And also we need to provide the elastic the data as well, and this one Young modulus is going to be 5E7, and Poisson ratio 0.3. Click on OK. And finally TNT, and density is going to be 1650, and for mechanical EOS here go to JWL and then go from the top here, copy this one and paste it at the bottom here, and then for this one 6E6, this one 0, and detonation point I'm gonna make everything 0 here, so no delay time, and the coordinate system is going to be 0 0 0. Click on OK. Okay, now I need to create a Eulerian domain, so it's going to be domain and solid Eulerian, continue, and now I'm going to add all the material that I just created, so air inter sol inter TNT and OK, and I'm going to assign this one to this. So currently my domain has everything. It has air, it has sol, and it has TNT as well, but software at the moment consider the full volume as a void, which means that it knows that there are materials, but we didn't really specify where is the location of those material. That we're going to do that in the load section. So now we are done with the property. I'm going to go to assembly. I'm going to bring our part, and then I'm going to move this one slightly up to put the coordinate system in the middle. So I'm going to select everything. The first one is going to be 0 0 0, so press enter. The second one 0 0.1 and 0, and as you can see the coordinate system located in the middle. Click on OK. Then we are done with this one. Next step, I'm going to select the solver, create a step, go to dynamic explicit, continue, and select give a time 0.003. I think that would be enough, very small value. Click on OK, and then for output click on edit this one, increase the number of the interval, make it 100 to have a smoother animation and more data point. And then here you can cancel a contact because there is just a one part, there is no contact, we don't have any failure. And from volume here you can activate the element volume, and also you can activate this one, which is a volume average material density. Click on OK, dismiss, and then in interaction we don't have to do anything because we only have one part, there is no contact. So I'm gonna skip this part, and then I'm gonna go to low. And as I said that, because we're gonna do kind of like a 3D 2D model, so what I'm gonna do, I'm gonna make the movement of this face and the face at the back 0. How we can do this? By making a velocity in these faces 0. So I'm gonna click on this velocity initial step, hold shift, select this face and this face, and then rotate a model, select this face and this face, and then click on OK, and make that one fix in Z direction. Then create another one, select everything, and then hold the control and cancel these two at the top, and then click on done. So we only selected the one at the edges on the right and left side, and I'm gonna make the X 0 in that direction. Click on OK. Then again the same thing, select everything, this time hold the control, cancel the middle one, done, and I'm gonna fix the Y this time. Now click on OK. So now we are done with the boundary condition. I'm gonna assign a material now to the correct location. So go to the predefined field, and in the initial step, material assignment, click on continue, select the Eulerian part, and as you can see here we have a region, domain air, domain sol, and domain TNT. Everything is 0 and the void is 1. So the value varies between 0 to 1. Now double click on here, region, and then go to set and select the air. This is the set that we created. So I'm going to select this one, continue, and then here I can give a value to this one 1. So if I make this one 1, you see that we're going to have a full volume air, no sol, no TNT, no void. But I can actually make this one 0.5. You can see that we're going to have half of it air, half of it void. So let's make this one 0 1. Then right click, add a row, double click, select the soil this time, continue, and make a soil one. Again, add a row, double click, select TNT this time, continue, and make a TNT one. So now we have air, soil, and TNT in the correct location. So now click on OK. Then go to mesh section, go to part, and as you can see at the top we have a structure mesh, at the bottom we have a sweep mesh. So I'm going to create more partition to make everything green and to have a structure mesh. We can do that by going to here, select this partition, done, select the point and normal, zoom in, select this point and this normal, create a partition, and then select this partition, done, point and normal, select this one and this one, create partition. So as you can see now we have everything in a green color. Then I'm going to assign a seed to edges, and for the size I will say 0.1. So this is quite good for this tutorial, but if I wanted to do that like for a real example, probably I would have gone for this one, especially like you can use a single bias and make the mesh smaller around this area that explosion happened. And of course the smaller mesh will give you a better result and also a better animation. So, but for this tutorial I'm going to keep this one 0.1 because we're going to get a result quickly. Apply, and then for element type select everything, and then explicit Eulerian, assign a mesh, yes. Okay, so this is our mesh. Now I'm gonna make this one smaller. I'm gonna create a job. I'm gonna say CEL creator soil number 1, click on OK, and then I'm gonna submit the job. I'm gonna check if we're gonna get any error here. So far no error, and I don't think this simulation will take a long time. It should be very quick. So as you can see that the CPU time is very small, 0.2, and now we are already in 0.002, that the time that we gave is 0.003. so now the simulation is done. So I'm gonna go to dismiss results, and then what I'm gonna do, I'm gonna activate the plot, then go here, free edges, or this one is better, feature edges, click on OK. So now from the top here I'm gonna go to air, and as you can see this is a mushroom shape. If I zoom in, you see that we can see these elements, they are not mixed to each other perfectly. How you can solve this one, you can go here, make this 75 to 100, apply this one. Now you're going to have a smoother plot. So let's activate the animation, and you're going to see that how the explosion happened on the air. And from here we can go to the soil, and you can see that this is a created by explosion. And as you can see, these green lines are basically a soil spreaded on the air, and then we're going to have a TNT as well. Also, what we can do, basically we can go here, and then if I activate for instance TNT, you're going to see that the TNT is going to get removed here, and we can actually see the volume of TNT. And then we can do the same for soil, and if I go to the soil plot, you're going to see that this is basically, if I stop the animation, so basically this area that it got removed is a soil, because once the explosion happened, this soil spread on the and also if you make your domain slightly bigger and also increase the time, you would see that after a while this soul will come back to this area here. And I'm gonna cancel this one, and I'm gonna go to air, and then again if you play animation, you're gonna see that this is the explosion wave basically in the air. Another thing that you can do, you can also see the velocity, and if I cancel this one, what we can do basically, you see that, what we can do, we can go here, add everything, and for instance I want to see the like a velocity on a specific node, so I can go here, create a XY data, create ODB field output, and then from here I'm going to make this one unique nodal element, delete, and I'm going to for instance select 1 point here, done. And then from variables I'm going to go at the bottom here, select the magnitude and apply, and as you can see here suddenly goes up to 3000 meters per second, and then after, when the explosion wave leaves that area, the velocity goes down. And of course if you increase the time, that this velocity is going to finally reach to 0 in that area. And for instance I can select this point instead of that, and if I plot this one, you're gonna see that it took a longer time until the explosion wave reached to that area. And as you can see, once the explosion wave reached to that area, the velocity decreased by 500 meters per second. So close to the explosion, the maximum velocity was 3000 meters per second. Now here is around 2500. Of course, when it reached to the higher here, for instance the last element, we can try this one as well, like for instance this one, done, plot, you're gonna see that it reached to around 1500 newtons. So and this is obvious, that happened because of the friction between air and also explosion wave. And then when this explosion wave moves, the velocity of course will reduce in the further domain. So basically this is everything for this tutorial. You can extract any other data that you're looking for. For instance, you can do it for a displacement or anything else. I hope you enjoyed this tutorial. Thank you so much for watching.